All right, guys, here we go. I am recording, and then we'll see if it works this time around. Okay, so what we did yesterday is we figured out that this, as a number of rectangles approaching infinity, that this means the area, exact area under curves between x equals a to x equals b. So all that means is this. Well, I guess let's see. Scenario 1, all area above the x-axis. So what does that mean? It means that this will give me, here's a, here's b. I have a curve. I'm going to call that curve f of x. And that will give me all the area below that curve. And if it's all above the x-axis, that area will always be positive. Area itself is always positive, but we're talking about signed area. So here's how you say positive. So what are we talking about? Signed area. Are we okay? All right. Now this one says some area above the x-axis, some area below. Depending on, so here's A, here's B. So it's area between the axis and the curve. So it's all this. And on the other one, it's this part right there. If there's more area above the x-axis than below, then it's positive. The integral is positive. This integral from a to b of f of x dx. If there's more area below the x-axis than above, then the area would be, the signed area would be, what do you think? Yes. If there's more area below the x-axis than above, then my integral would be negative. And if there's the same amount of area above the x-axis as below the x-axis, then the signed area would be 0. Because you have, this is signed area. So if this area here above is 5 and this area below here is 5 as well, the integral from a to b is going to cancel each other out. I have 5 above, I have 5 below. 5 plus negative 5, 0. You know what I mean? You sure? Okay. And here we go. I'm going to use burnt orange for UT. Just by coincidence. That's A, that's B. If I have a curve below the x-axis all the time, and I find this area itself is always positive, guys, but the integrand from a to b of f of x dx, what it calculates, because remember, all I'm doing is width times height for the rectangle, and when it calculates the height, it calculates a negative f of x value, right, because it's below the x-axis. So when I add this up, it's going to be a negative number, so I'm going to write less than 0. If the area is below the x-axis, the integrand will give you a negative number. Does that make sense to you guys? Nothing crazy, right? Okay. Did you get the email? I just sent it to you. Okay. So if you can recreate that file, make it all nice and pretty and all that good stuff. Okay. How do we feel, guys? Do we feel okay? All right. Here we go. This is just a review. Upper limit, that's just C. Upper limit. B, this is where you stop. This is where you start. Lower limit, upper limit, you got to have an f of x. That's my height, and you got to have a dx. That acts like delta x, like, quote unquote, delta x. That's like saying width times height, width times height, width times height. And that elongated s, you're going to add an infinite amount of rectangles. Just like what we did yesterday. You still okay? Okay. Is everyone still all right? All right. Okay. It does not matter what you call the letter. X-axis, it does not matter what you call the x-axis. You can call the letter T, letter U, letter X, letter G. If it's a definite integral, meaning there's numbers on the lower and the upper, it's going to stay the same, like that value. Chav, what are you talking about? Well, you'll see right now in a little bit. Here are some properties. I don't like that they switched them BA, AB. If you want to switch AB there and then switch them here, BA. All the other ones, the lower limit starts with an A, but that's fine, not a big deal. Notice that they switched the limits. I did start at A and then I ended at B, and now I start at B and I end at A. And those are the same X values. Don't worry, we're going to talk about them right now with a picture. What's up? Are you talking about number 2? Oh, we're not there yet, but don't worry, we'll get there. All right, so let's see why there's that negative there. So let's just do a picture with everything above the x-axis. So this is for number 1, order of integration. So right now, the integral from a to b of this f of x dx is positive. Do you guys all agree? All right. If I switch my limits, and notice I'm not putting a negative in there because I'm going to be forcing, you'll see what I mean, of x dx. If I switch my limits, let me see if I can explain this correctly. The red one here, I start at a and I stop at b. I'm still talking about the same function. I should have labeled f of x. I'm sorry. Now if I start at b, notice where I start, and I travel towards a, well, if a is something like 1 or 2, and b is something like 5 or 6, notice we're going backwards. I'm starting at 5 or 6, and I'm approaching 1 or 2. So if I approach backwards, then this is going to have to be negative. Does that make sense? So in essence, what does that mean? That means if I switch my limits, you can just put a negative in the front. Yes.
Is that it in blue? Is that a 0?
Yeah, that's how you say negative, less than 0. Right?
Oh, okay, yes, I was looking.
Yeah, anything that's less than 0 is going to be negative?
Yeah.
Okay. Are we okay, guys? Okay. So there it is. If you want to make a statement between both of those, well then yeah, a to b of f of x dx will give you, put a negative in the front, b to a of f of x dx. It's going to be the same thing, but whatever that is, negative. Because you're counting backwards. Does that make sense to everyone, guys? Okay, here we go. So here you go, Ms. Johnson. What about this one? Why is that one 0? Well, here's number 2. If I go from A to A, have you moved? No, you're just there. You're still at that same location. You're right here. This is f of x. You haven't moved, guys. So if you haven't moved, how do you have area? You haven't moved. Does that make sense?
Yes.
Okay, so there it is. That's why this is always 0, because there is no area if you haven't moved. There is no rectangles. Hey, no, Yanni, that's demerit, miss. How many demerits am I going to have to write? This is ridiculous. Okay. Constant multiple. Notice if you guys already have a little bit of experience with this. If there's a constant, you can just pull that out. Just like with limits, it's the same deal. Notice that there is no f of x times g of x property here. Well, okay, I'll let your professor handle that. There is other things, other limit rules, other integration rules, but we're not advanced yet. This is rookie numbers. So, okay, are we still okay? All right. And then, of course, this is the same thing as saying -1. There's it is, and there's my k constant -1. All right, some difference. As long as the limits are the same, if you have f of x plus g of x or f of x minus g of x, you can spread them apart. You can see the limits are still the same, a, b. You can go f of x dx plus or minus from a to b of g of x dx. I think that one's pretty straightforward. I don't think we necessarily need anything on that. That's also the same with limits as well. Are we still okay? Okay, so some of these properties are the same. Now here we go. I'm going to draw a picture for this one because sometimes this one, I think it's logic, but just in case. All right, so I'm going to draw, here's a y-axis, here's an x-axis, here's A, here's B, and here's C, and here's a curve, and I'm going to call that f of x. And as a matter of fact, we'll even color code it. Here's A, from A to B, this is blue, and we'll do black. From B to C, this is black. So let's see if I can draw what it says. So blue, so I'm going to write integral from A to B of f of x dx. That's what the area under the blue is. Plus, red is neutral because red is just my whatever. Red is just my x-axis, y-axis, and the curve. Plus whatever I have in black, integral from B to C of f of x dx. And what does that give me? Well, let's see. Now slow down. Do you agree that if I take everything in blue and if I add everything in black, that is area under the f of x curve from A all the way to C? And notice that's what it says, from A all the way to C of that curve. Cool or not cool? All right, so here we go. That equals area under the curve from A to C of f of x dx. So, one quick observation. Notice wherever the area of blue stops, the area in black better start. Start at A, stop at blue, at B. Start at B, wherever this one stops, we're going to start at B, stop at C. We got it. We got it. I think we're good now.
And there
Yeah.
can be multiple sections within that.
Yeah, of course. Of course. But we're rookies, so we got to just start with baby steps. All right, guys, here we go. Oh, by the way, like I said before, it doesn't matter what I call the axis. So see, it doesn't matter what you call this axis, X, comma, or G, comma, H, comma, T. Like if these are discrete numbers, if these are finite numbers, then they're always going to add up to that, regardless of what you call the axis. You guys know what I mean? Okay, here we go. So here's what they tell you, and you don't know how this curve looks like. All we know is you start at -3 and you stop at 0. On a number line, -3 is to the left and 0 is to the right, so we're good right now. And this area is square root of 2. That's all we know right now. So letter A, what did they do to the limits? They flipped them. So whenever you flip the limits, so now I'm starting at 0 and counting towards -3. So now I'm going backwards. So what is this going to output? Negative square root of 2. See, you guys already got it. All right, my lower limit is -3. My upper limit is 0. They're calling the axis now U. Does it matter what I call the axis? No. What is this going to output? Positive square root of 2. Are we still okay? Letter C. They put a negative in front of that g of x. That acts like a constant. I can take it out. Negative in the front. Integral. -3 to 0 of g of x dx. This that I'm putting in brackets, I already have that value. That's just what? Square root of 2. So this is going to give me negative square root of 2. Are we okay? Am I going too fast or am I going at an okay speed? Okay. I'm going to rewrite this so you can see it. Chop, I don't know. There's nothing in here about dividing. Guys, this can be written like this. Integral, -3 to 0. That was supposed to be you guys. Oh, another yawn you do. Oh, okay. I see how it's going to be, miss. I'm going to take this. Yeah, you're going to make me yawn, miss. I just finished my energy drink. And you take this 1 over square root of 2. That's just a constant. Do you guys see that? I can pull that constant outside the integrand. That's what that elongated, that's what you call that elongated symbol, the integral, the integrand. 1 over square root of 2 integral, and these are definite integrals because I have a lower limit and an upper limit. -3 to 0 of g of r dr. It doesn't matter what you call the x-axis. You can call it any letter. They called it r. So this is 1 over square root of 2 times, what is this integrand? Times square root of 2. So I'm just going to get 1. And there it is. We just finished those. What do you guys think so far? Yeah, not bad. Let's move up a little bit. Now I have 2 functions. Oh, so now you're moving that way so I don't see the yawn. Suppose that f and g are continuous. Yeah, get up. Functions and that. Do I have a standing desk somewhere? Okay. So here it is. Here's f of x. Here's g of x. Guys, just because it's negative does not mean that the entire graph is below the x-axis. Oh, don't think I can't see you yawning behind that mask there. Okay. I can see everything now because I took an energy drink and hear everything. Okay, anyways. Guys, all that means is that I have more below the x-axis than above. It could be all below. So this is just for you to know. I could have everything below. It could be like this, 1 and 2, and then all this is below. So, of course, in my area, there is 4. It could be that, or it could be, Ms. Johnson, I saw that. Or it could be, like here's 1, here's 2, and it could look like this, where, and I know I'm exaggerating, not to scale, where this area here is 6, and this area here is 2. It could be like that. Do you guys see that? Okay, that's just something for you to note, where I call this f of x and I call this f of x. That's just something for you to note. Okay, I'm going to erase this because it's not part of this. So those are just the properties. Okay. Yeah, well, they were correct, but we don't know how f of x looks. They don't give us a function, right? They just tell us they're continuous and those values. Okay, from 2 to 2, have I moved? So what's this area? 0. Letter B. Yeah.
Why did it change into the two?
Well, it doesn't like. First of all, they don't even give us for g of x anything about 2, but we know that I start at 2 and I stop at 2. So has it moved? So any function from 2 to 2 is going to be the same. It's going to be 0. Of course, we're talking about continuous functions to make it simple, but okay. All right, look at this one. This one has a lower limit of 5, upper limit of 1, and I have g of x in there. So here it was 1, lower limit, upper limit 5. What happened to those limits? They switch. Yeah, and when I say limits, I'm not talking about a literal limit, like limit as x approaches. I'm talking about what I have in the upper and what I have in the lower. That is what they call them, guys. See? Upper limit, lower limit. That's just terminology, common terminology. And just in case I've seen people get confused there. Okay, so there it is. So my limits have been switched. My upper is now my lower is now my upper. So this is going to be -8. Are we okay? Letter C, I have a 3 in front of that f of x. Put the 3 on the front. Integral 1 to 2 of f of x dx. I already know what the integral from 1 to 2 of f of x dx is. Look up there. What is that integral from 1 to 2 of f of x dx? -4. So what is 3 times -4? -12. There it is. Child, what about this one? This one's different. Okay. I'm going to draw a picture, and I'm just drawing it not to scale. Not to scale, because I'm going to force it to be positive. Obviously, between 1 and 2, I got to have some area below the x-axis because it's -4. But look, I'm saying not to scale. This is just for illustration purposes. Are we okay? Okay, I'm going to say here's 1. It says 1, 2. I'm going to say here's 2. And I'm going to say here's 4. And I have some function. I'm going to call that f of x. Make sure that you put that it's not to scale. This is just for notes. So if I have the area from 1 to 2, and I'm going to do this one in black. And if I have the area from 1 to 5, I'm going to do that one in blue. Oh, was that 5? F of x? Yeah. Let me change that 4 to a 5. Change that 4 to a 5, guys. Oh. 5. That's good enough. Okay. So what do I have the area from? From 1 to 5. Okay. So here's 5. And look, I'm doing it in blue. Okay. This is just like algebra. So help me out here. Ready? If I take the area in blue, which is from 1 to 5, and I subtract the area in black from 1 to 2, won't that give me the area from 2 to 5? Do you see that? So here's my hack. Obviously, the area from 1 to 2 needs to be below the x-axis, at least some of it. But there it is. So not to scale. So what did I do? So here's my hack. So I took the area from 1 to 5. So I'm gonna write that in blue. So here it is. I'm gonna write area from 1 to 5 of f of x dx, and I'm gonna subtract the area from 1 to 2 of f of x dx, and that will give me the area from 2 to 5. And let me move that f of x so you guys don't get confused. So I take the area in the blue, I subtract the area in black, and do you guys agree that will give me the area from 2 to 5? So there it is. So now I'm gonna write this out here. So area from 2 to 5 is equal to, what's the area from 1 to 5? 6. That's the blue part. Minus, and I know this is why I put not to scale. What's the area from 1 to 2? What is it? -4. Yeah, I know. I don't have it below the x-axis. What is 6 minus -4? 10. Does everyone see how we did it? Johnson, hit me.
Wait, I don't get it from this. Like, I know it's not scale, but like, it turns positive for this one.
Well, yeah. Well, I'm just subtracting because of this a lot. You're right. The area in black, I should have some. Maybe it's all below the x-axis. I don't know. But if you want the area from 2 to 5, well, this is just for logic reasons. Well, if I take the area from 1 to 5 and I subtract the area from 1 to 2, won't that give me just the area from 2 to 5? So that's the logic. We don't know how it really looks, how it actually looks. So I just took the area from 1 to 5, which was 6, and and I take the area from 1 to 2, which happened to be -4, so 6 minus -4, and it gave me 10. Do you see the logic?
Yeah.
Okay, for sure. You're not just telling me that just to tell me that.
No.
Okay. Okay. Let's go to letter E. It says area from 1 to 5 of f of x. I do have that. And it says area from 1 to 5 of g of x. I do have that as well. So this is, I guess, for good notes, I'm going to write 1 to 5 of f of x dx minus integral 1 to 5 of g of x dx. You got to have that dx in there, guys. You got to have that differential. Area from 1 to 5 of f of x is, 6. Area of g of x from 1 to 5, what's 6 minus 8? There's the answer, -2. Are we still okay, guys? All right, letter F. So let's see what this is. I'm going to rewrite this. Area under the curve from 1 to 5 of 4 put on the outside, f of x, that's a constant. Put the dx in there, it closes. Minus area under the curve from 1 to 5 of g of x dx. I think we're good. 4 times, what's area under the curve from 1 to 5 of f of x? 4 times 6. Minus, what's area under the curve from 1 to 5 of g of x? 8. Oh, 4 times 6 is 24 minus 8, which is that 16? I know it's late, it's evening, and everyone's tired, especially after lunch. This is why lab in the morning, I think, is better than lab in the evening. Second period is actually the perfect time. So calculus, second period, is perfect for calc. All right, here we go. Suppose, and these are the answers they give me in -1 to 1. They don't tell me anything about even or odd. So look what they did. 1 to 4. Well, here it is, f of x from 1 to 4. Now they go from 4 to 1. So instead of -2, this is going to be +2. There it is. Just put 2. And it does say, suppose that find each of the following intervals if possible. So underline the if possible because there's going to be some that are not. All right. Integral from -1 to 4. Well, check it out. I have the integral from -1 to 1. When this one stops, look at the other one. That one, the other integrand begins. Do you guys see that? So this is the same thing as saying integral from -1 to 1 of f of x dx plus integral from 1 to 4 of f of x dx. So it's going to be 5 plus -2, which equals 3. How do we feel, guys? Okay, let's go to the next one. 2, I'm just rewriting it. Integral -1 to 1 of f of x dx plus 3 integral -1 to 1 of h of x dx. Those are just constants. And there's a plus in the middle. So 2 times from -1 to 1, it was what? 5. Plus 3 times -1 to 1 of h of x was, or is, 7. So 2 times 5 is 10. 7 times 3 is 21. 21 plus 10, 31. Yay or nay? Okay. 0 to 1. All right. There's no way that you can take this and subtract this. Nope, that's not going to give us anything. That's going to give us one. No, there's no way. So is this one possible? At the moment, not possible. There's one scenario where it would have been possible. Let me explain that scenario. If they would have told us, they don't, but if they would have told us that f of x is an even function, even functions are symmetric about what axis? The y. Notice, -1 to 1 is equal distance from the y-axis by a space of 1. If they would have told us that f of x is even, we just would have cut that in half. If they would have told us that f of x is odd, remember all our functions go from the origin. Well, actually, it wouldn't have been possible because if it would have been odd, that would have been 0 because the areas cancel each other out. But the even one would have been possible. If they told us f of x is even and it's symmetric about the y-axis, like this one, 0 to 1, then we would have just cut that area in half. But that's not the case here. They don't tell us that. Are we cool?
Even if they're different, like start and end.
Well, no, if they're different start and ends, then we don't know.
Well, like for 2 and
Like-
-2, they're different.
Oh, well, they would have told you 2 and -2. then and they tell us it's even, then we just cut it in half.
Okay.
It has to be equidistant from the y-axis. These numbers have to be opposite magnitudes.
Okay.
Opposite, yeah. Same magnitudes, one positive, one negative. And f of x even for us to do that hack. Cool or not cool? All right, negative 2 to 2. Well, for h of x, we only know between negative 1 and 1. Negative 2 is outside the range, or I guess outside the domain technically. Does that make sense? Not possible. Negative 1 to 4. Do I have enough for the h of x? No, we only know from negative 1 to 1 for h of x. Again, this one is?
It's would have been possible if you were to switch the one and negative one.
Well, they have to give me, I only know up to 1. I don't know what's happening at 2, 3, and 4. It is all they give me. Suppose block. If the following growth is possible. If they give you more information, you just want it.
So you're going to give us an answer for a question that's not possible.
Maybe right now, but usually, like on like the release exams or whatever, you probably won't find that because they're trying to see if you can really decipher the influence and all that. You know what I mean? But probably not. All right, here we go, guys. Here's how your delta is going to look today.
Oh.
That and geometry. Relax. Yeah, like do you know rectangles and trapezoids, and they don't give you circles, right? Because I put level 1. Yeah. So it's just triangles, rectangles, and trapezoids, which really you can turn a trapezoid into a rectangle and a triangle. All right, here we go. The regions A, B, and C in the figure below are bounded by the graphs of the function f and the x-axis. The area of region A is 18, so I'm going to put 18 right there. 18. The area of region B is 14, so I'm going to put 14. And the area of region C is 8, so I'm going to put 8. Because areas can only be positive, right? What is the value of the integrand from negative 5 to 8 of f of x dx? Okay, so negative 5 is right here, so I'm going to put a point there, negative 5. And 8 is right here. Do you guys see that? Okay, remember what we said. For the integrand, if you're below the x-axis, then that number is going to be negative, and if you're above the x-axis, that number is going to be positive. So this is, to be technical, this is talking about signed area. Every time you see an integrand, you're always going to be talking about signed area. It has meaning. Later on, we're going to be adding context to it. It could mean distance. It could mean well, we're not there yet, so let's just do baby steps. You guys ready? All right, from negative 5 to 8, I go to negative 5. From negative 5 to 0, I see that I'm below the x-axis. Negative 18. Plus, from 0 to 4, I see that I'm again below the x-axis, so I'm going to write negative 14. Plus, from 4 to 8, am I above the x-axis or below? 8. Add them all up. Negative 18 plus 14, or negative 14, 18, 28, negative 32, and then I add 8 to it. Yeah, negative, is it 24? There it is. How do we feel? There it is. And really, that's how simple it is that I didn't write any more problems. I guess, you know what, a side note for problems. Integral from negative 5 to 0 of f of x dx is negative 18. Integral from 0 to 4 of f of x dx is negative 14. Integral from 4 to 8 of f of x dx is 8. Are we still okay? Okay, as a bonus, here's the bonus stuff. Integral from 0 to negative 5 of f of x dx, I'm counting backwards, 18. Integral from 4 to 0 of f of x dx, I'm counting backwards again, 14. Do you guys see what we're doing? Integral from 8 to 4 of f of x dx, negative 8. And then if these were to be linear lines, you guys know how to calculate triangles and rectangles, right? All right, guys, that's it. So it's just getting more practice. And then tomorrow we'll have a short activity, short notes, and we'll call it a day.